Finally tonight here, get ready for takeoff. No plane needed, just a jet suit. Move over Iron Man.
Jetpack technology has gone from science fiction to fact. With cutting-edge design and pinpoint precision engineering, these individual flight systems have come a long way. From the Bell rocket belt to current innovations, British inventors have made military personnel into contemporary Iron Men with state-of-the-art propulsion. Jetpacks, which have been a mainstay of science fiction for so long, are here, and they are doing incredible things. Join us as we explore 15 creative jetpacks that are revolutionizing the world and making human flight a reality like never before. But while the dream of flight has dazzled imaginations for decades, one machine is turning that dream into a tactical reality. What happens when 6 turbojets meet a single human body? Ready for liftoff? JB12 Jetpack. Jetpack aviation is at the vanguard of air innovation, transforming human flight abilities through state-of-the-art technology. As trailblazers in personal airborne transportation, they've developed the JB12 Jetpack, a staggering feat that is the epitome of today's aerospace engineering. Entirely manufactured in the United States of America, this sophisticated machine is a reflection of American ingenuity in aircraft technology. The JB12 is the newest model in an ongoing, evolving series of personal flight gear specifically engineered to provide superior aerodynamic capabilities. Its propulsion system consists of 6 high-precision turbojet engines that provide never-before-seen amounts of balance, direction control, and thrust management for flight operations. These new capabilities are particularly significant in high-speed operations and real-terrain obstacle evasion. Military and rescue response usage was primarily driven by the JB12 development. The device's general-purpose utility is of use for a wide range of tactical missions, such as rapid deployment missions, hard rescue missions, and reconnaissance missions where conventional transport is impractical. Pilots obtain the capability to fly in space with breathtaking accuracy on an intuitive dual-joystick flight control system through innovative engineering solutions by Jetpack Aviation. With a system well-suited for the intuitive control of airspeed, altitude, and trajectory in flight, exceptional usability is the top priority. Anything conceptual, the JB12 was tested thoroughly under actual usage and validated. Its small size is a strategic treasure, something that allows instant deployment, man-pack portability, and storage in cramped spaces. Such a feature is priceless for military forces needing instant mobilization capacity without the logistical cost of heavy equipment. With the intersection of phenomenal thrust generation and rapid-acting architecture, the JB12 is nothing short of flying machinery. It's an advanced tactical tool. Yes, a flying device that does everything but land. The implications of this technology are massive, envisioning a ground-up revision in how military personnel and emergency response teams carry out essential missions. As technology continues to advance ever more rapidly, the idea of jetpacks as a standard military issue seems all the more likely. The addition of such technology could revolutionize battlefield mobility and emergency response procedures, maybe even breaking into a new age of tactical operations. But before the JB12 ever lifted a boot off the ground, one iconic machine lit the fuse. Where did this revolution begin? And how did a Cold War-era gadget become the spark for a global jetpack race? Bell Rocket Belt. Modern technology's lineage is through a phenomenal creation, the Bell Rocket Belt. The initial jetpack initiated personal flying. American engineers created this phenomenon during the 1960s, propelled by hydrogen peroxide. The invention earned its place in film history as a memorable part of the James Bond film Thunderball, becoming part of mainstream culture. The propulsion system worked by decomposing hydrogen peroxide into a high-pressure oxygen and steam mixture. Capable of propelling an individual through the air for some 20 seconds, the Bell Rocket Belt achieved phenomenal performance statistics, 30-foot altitudes, and 60-mile-per-hour speeds. Smaller by today's standards, this record was revolutionary for its day. Originally intended for military purposes, The aircraft was heavily tested for emergency response operations and rapid troop deployment. The flight time was restricted, and maneuverability during flight was challenging, so it was never used in combat service. However, through the program, something extraordinary was demonstrated. Flight by a single human being had become a reality. Jetmans Ground to Sky. In a record-breaking feat that transformed aviation history, Vince Refet accomplished the impossible, which the majority of people believed was unachievable. Unlike conventional jet-powered adventurers who exploited helicopters or aircraft to propel themselves, he pursued a completely different route. With his feet still on the ground, he achieved what would be one of the most significant achievements in aviation history. He began his remarkable journey in Dubai, where he collaborated with the creative Jetman Dubai team. They collaboratively developed a revolutionary carbon fiber jet wing system that would challenge conventional wisdom on the possibilities of human flight. The innovative system was equipped with 4 miniature turbojet engines, sleekly integrated into its aerodynamic shape. The truly innovative feature of this invention was the control system. While conventional aircraft are navigated through mechanical controls, this system was navigated purely through the physical movements of the pilot. The record attempt was made with calculated precision. From a specially constructed elevated platform, Refet flew. His initial seconds airborne were characterized by careful assessment, dangling for an instant to probe the performance of the wing. Then, in a demonstration of command of control, he pushed the machine upwards with great force.
But first, we wanted to do it a long time ago because a French guy, he did a similar stunt 20 years ago where he jumped from a plane and we re-entered the plane.
The figures merely tell an incredible story, rising to altitudes near 6,000 feet while reaching speeds of more than 150 miles per hour. Most notably, perhaps, he demonstrated complete command of the aircraft's movement, executing sophisticated maneuvers with a lightness of touch that was like a bird of prey swooping overhead. What distinguished this achievement from spectacle was its profound significance to aviation technology. Although it was deemed by many to be a fantastic stunt, it was more than that. Ultimate proof that human beings could accomplish sustained, controlled flight without the assistance of traditional aircraft or complex launching mechanisms. The fact that it was achieved without recourse to computer-assisted navigation systems only made the accomplishment more spectacular, because it was based solely on the symphonic harmony between pilot and craft. Though Vince Refet's life was so pointlessly cut short during a later flight training exercise, his pioneering accomplishment remains an inspiration for future innovations in personal flight technology. His successful demonstration of a vertical takeoff capability by utilizing a jet-powered wing system is a marvel of human innovation and an adamant refusal to believe what is perceived as the impossible. His achievement today is a cornerstone to the evolution of personal flight systems and offers us hope that even the most perceived to be impossible challenge can be overcome through determination, technological evolution, and unyielding courage. Thunderpack TPR2G2. The TPR2G2 carries much more than traditional jetpack technology. Its innovative coupling of advanced design and mind-bending power carries unparalleled technological sophistication. Tactical leaders and civilian adventurers have equal claim to this airplane's potential. The TPR2G2's power plant can support phenomenal speed and flight altitude capacity, and so it is severely capable of tactical assignment as well as breathtaking spectacle. One of the most excellent features of the Thunderpack is its highly advanced system of balance. Unlike risky do-it-yourself gadgets that might have their pilots suspended in mid-air, this highly developed device offers smooth, stable flight. It has high fuel efficiency so that it can stay in flight for longer durations, and this makes it a practical device and not a fad gadget. What is so fascinating about the TPR2G2 is that it is a direct offshoot of the original TPR1G2 design. This next version has amazing improvements in sustained flight times, maneuverability, and overall safety features. As a second-generation propulsion system, it offers a preview of things to come for aviation, when humans will be flying through airspaces with the kinetic freedom usually reserved for action movies. Maverick Jetpack. Imagine travelling back to the dawn of personal flight technology, when New Zealand took its place as the unlikely champion of the field. The Martin Jetpack, brought to life by visionary inventor Glenn Martin, was one of our first serious attempts to turn science fiction into an everyday fact. What really made it different from today's turbine-powered backpacks, so advanced, is that it went about it another way. Instead of attempting to utilize small turbines, it employed high-powered ducted fans in a twin vertical turboprop setup, which gave it the brute force to propel a human over 3,000 feet into the air.
Martin Aircraft Company made the Martin Jetpack, decided he was going to dedicate his life to creating this machine. This is the Martin Jetpack.
From the moment it appeared in the mid-2000s, the Martin Jetpack was in the news. And for good reason. This was no flashy, publicity-seeking gimmickry. This was a well-considered machine designed with real-world daily applications in mind, from delivering emergency responders to disaster sites in a hurry to helping soldiers achieve their missions to carrying out painstaking industrial site inspections. Underneath its daunting appearance, the jetpack was equipped with cutting-edge tech, a carbon fiber frame that was both light and phenomenally strong, built-in safety measures, and computerized flight systems that were years ahead of their time. While the company itself closed its doors in 2019, the Martin Jetpack's legacy endures. Instead of taking its place in the history books, it paved the way for an entirely new generation of personal flight vehicles, rendering vertical human flight not a dream, but an achievable reality. But just when the world thought the jetpack revolution had hit cruising altitude, another contender burst through the clouds. What happens when raw speed meets sleek design and takes personal flight to cinematic levels? The Flash Jetpack didn't just raise the bar, it redefined the sky itself. Flash Jetpack. Jetpacks have been the quintessential symbol of the future of transportation for decades, holding us in awe. However, with recent technological achievements, this notion of impossibility is now a tangible reality. The innovation breakthrough that has been revealed marks a new paradigm shift in aviation innovation, fundamentally altering our vision of personal flight capability forever. You find yourself soaring in the air with full liberty, spanning the boundaries of conventional gravity without being weighed down by the burdens of conventional infrastructure. That divine concept, so far relegated to the confines of science fiction books, became far too real. The early 21st century witnessed the imprint of human history etched irrevocably by the launch of the revolutionary Flash technology, a discovery that rocked the very foundations of the technical world. Developed by a group of early mechanical engineers with a genius vision, this fantastic machine was much superior to that of typical novelty material. Its streamlined, futuristic body housed advanced aerodynamics, a high-speed flight device that could reach 120 miles per hour, unlike millions of conceptual blueprints that were bound to be relegated to oblivion. This innovation was vigorously tested within actual operating conditions and was found to be practically viable in actual operating conditions. Picture the theatrics of witnessing a personal flight machine glide through city airways in much the same smooth style that a conventional motorcycle travels through ground terrain. The sheer scale of the accomplishment itself is awe-inspiring. The most singular aspect of the Flash design might have been its revolutionary propulsion system, in the form of two miniature turbofan units carefully engineered to generate sufficient lifting force to elevate human pilots into the air above the Earth's surface. Other than that, the history of the project in human terms made the tale all the more fascinating. Rather than being built in a corporate research facility that was well capitalized, this extraordinary accomplishment was achieved by committed inventors with a small workshop of their own invention. This device is a milestone in the history of flight, challenging prevailing paradigms and extending the boundaries of what was otherwise achievable. Not surprisingly, many questions were asked about the invention's design parameters and usability in practice. These questions involved, for example, whether it would be possible for it to maintain flight with travel times of several hours' duration, whether it would remain stable in gusty atmospheric conditions, and whether it could weather bad meteorological conditions. These challenges, although substantial, are the natural barriers inherent in revolutionary innovations of this type. Nevertheless, The successful development of the Flash Jetpack quantitatively gets us closer to realizing the long-standing aspiration of watching humans traverse the skies with super-heroic nimbleness. The possibility of encountering jetpacks in local aerodromes in the decade ahead begins to appear quite more likely, raising fascinating questions about the future landscape of personal mobility and transportation. UK's real-life Iron Man. Richard Browning and his UK-based company, Gravity Industries, have done something remarkable. Their gadget, a jet-powered suit, represents humanity's best attempt to date at replicating Iron Man technology in the real world. The device operates through 5 small but high-power gas turbines, churning out a combined power output of over 1,000 horsepower. This huge amount of energy enables users to cover speeds of more than 50 miles per hour and reach heights of 9,800 feet. What particularly distinguishes this technology, however, is not so much how well it can fly, but rather its sophisticated control systems. Pilots execute such complicated aerial maneuvers with mere adjustments in the placement of their arms. After extensive testing and redesigning at Gravity Industries.
So I suppose throughout my life, especially as a kid, I used to enjoy making things, taking things apart, working with my father in his workshop.
The suit has now become a solid platform for actual deployment, as with military operations. In fact, the UK Royal Marines have already conducted trials utilising the equipment for boarding ships. Far from being the stuff of fantasy, it is a modern technological progression. Moreover, would-be pilots can even take specialised courses offered by Gravity so that individuals can try out the suit firsthand under expert guidance. NASA's Jetpack in Space. Space travel has always fascinated mankind, particularly when it comes to personal propulsion gear. While jetpacks are no stranger to the planet Earth, their application in space is an engineering marvel. The development of the Manned Maneuvering Unit, MMU, was a monumental achievement in the history of space exploration, as NASA and Martin Marietta collaborated in the 1980s to create this phenomenal device. The MMU's design was a work of art in problem-solving in the aerospace engineering profession. Rather than employing conventional rocket propulsion, the designers opted for an elegant arrangement of 24 small thrusters. These were compact units fueled by compressed nitrogen as their propellant, which provided astronauts with unprecedented mobility in microgravity environments. The technology enabled space travelers to freely navigate on their own.
One of the most exciting things we did on my very first spaceflight,
without mechanical tethers to their spacecraft. A milestone in space travel was achieved in 1984 when astronaut Bruce McCandless II ventured further than any human had ever gone. In his historic spacewalk, he floated some 300 feet away from the Space Shuttle Challenger, where the MMU would serve to take him forward. The photograph taken of McCandless floating in space with the cosmic background turned out to be one of the most recognizable images in the history of space, symbolizing human potential to use technology to overcome hitherto apparently insurmountable barriers. The MMU's operational success was not so much a remarkable technical feat, it was a deeply significant mobility achievement for astronauts. While NASA subsequently abandoned the unit on safety grounds, its legacy still influences space operations today. Modern emergency maneuvering systems operated outside the International Space Station owe a debt of gratitude to the pioneering work that was performed under the MMU program. They combine enhanced safety features with the basic principle demonstrated by the MMU that individual-controlled spaceflight is not only feasible but essential for effective space station operations. Today's astronauts on extravehicular missions have the luxury of being able to make use of safer, more sophisticated propulsion units. The systems, though derivative of the work of the MMU, contain numerous advancements in design and function. This evolution from the MMU to the modern-day equipment shows how trailblazing advances can give way to increasingly finer technologies, ultimately to improve our ability for spacework and exploration. New Japanese Jetpack. Chinese and American engineering experts have been left amazed at the launch of Japan's new jetpack. As she performed her death-defying mid-air stunt near the skyscraper, the scene looked like it jumped straight out of a comic book. Japan's remarkable technological advances raise interesting questions about how they managed to outcompete their international competitors. Who is this tough-as-nails engineer bending classic physics principles with her propulsion system riding on her arm? The city skyline is the ideal setting for her firework contrails and magic-in-the-air display. It's obviously the real deal. What is this high new power source driving this historic flight? Apollo Jetpack. The sight of a person jetting through the air over a stadium at halftime or jetting above crowded carnival grounds typically means Jetpack International's Apollo Jetpack is available, rather than being reserved for testing or military units. This unit is created to deliver thrilling crowd experiences. Made on site and powered by hydrogen peroxide, the Apollo system emits hot vapor through two outlets to produce upward thrust, enabling operators to make sustained, controlled flight for a period of around half a minute. While such a duration might seem brief, these 30 seconds prove sufficient to impress vast audiences. The ones equipped with the Apollo gear can potentially fly off vertically, spin on their own, hover above air, and navigate across exactly choreographed flight maneuvers. Before liftoff even occurs, however, the unit's rumble, audible like a commercial jet airliner, is enough to command everyone's notice. Its peculiar nature stems from its very design ethos. Unlike the conventional kerosene-burning or turbojet systems, this model excels at creating energetic, localized activity hotspots. Ideal for entertainment, media production, and live exhibition, the technology requires neither wing-like structures nor extremely sophisticated control systems, just a pressurized vessel with two excellent exhaust vents projecting upward thrust. Throughout the globe, Jetpack International's professional operators have operated at diverse venues, from ceremonial parades and corporate conventions to television productions and cultural festivals. VR Jetpack. Imagine gliding through the air with greater mobility than ever before, flying a revolutionary jetpack that replicates your every movement. Such an incredible breakthrough is a quantum change from conventional flight, redesigning the very essence of flight itself. In the United Kingdom, innovative engineers at Air Oxo have made history in air technology. Their success, the Daedalus Flight Pack, is a product of man's ingenuity and high-tech engineering. Spearheading this breakthrough effort is the renowned British engineer Richard Mallet, whose innovative mind has compelled him to defy traditional presuppositions about flight. His vision far surpasses simple mechanical genius, seeking to transform completely both the physics and psychology of flight. The breathtaking innovation works through a wonderfully ingenious but intricate mechanism. Severely strapped to the pilot's back, the jetpack is fueled by an advanced hybrid drive system built from the ground up for stealth vertical flight. Its most impressive accomplishment is its flight control system of the future, a quantum leap over successful flight technology. Rather than the conventional control sticks or levers, co-pilots steer the plane with a cutting-edge virtual reality headset with sophisticated gesture recognition sensors. The control system is started in breathtaking intuitiveness. A wave of an arm executes a sharp turn, and a change in position executes climbing or descending. This silky, smooth coordination creates a beautiful dialogue between pilot and aircraft, converting every movement of the body into proficient flight control with ghostly accuracy. The cutting-edge virtual reality module is stretched to new limits. It transcends the mere display of basic measurements like height, speed, and trajectory. The high-end headwear provides an out-and-out immersive experience. It allows pilots to interact with highly detailed, simulated weather conditions and experience realistic training environments, all from the convenience of solid ground. Through strict testing protocols, the Daedalus Pack is humanity's most cutting-edge effort to date in the integration of man's intuition and machine's ability. This revolutionary technology surpasses the average of flight, transforming the very nature of flight itself. With this incredible feat, Air Oxo has achieved the impossible in bridging the gap between human nature and technological precision to come up with an unmatched flight experience that will forever alter private transport. But what if flight wasn't just about liftoff, but about domination? What if the skies bowed not to machines, but to men in suits, slicing through the clouds with rotors in their chests? The next chapter pushes that question to the edge, literally. Germany's Turbine Wingsuit. Imagine flying like a flying squirrel. It's fun and something that can tickle one's imagination, but attach jet-powered engines on your shoulders, and you become the master of the air in another dimension. The original concept represents the future of human flight beyond the boundaries of conventional sky exploration. Here, we see a stunning innovation from Germany that redefines traditional wingsuit flying as science fiction movie magic in real life. The Turbine Jet Wingsuit prototype is a testament to human ingenuity, a collaboration of Peter Salzmann, a longtime Austrian stuntman and skydiver, with BMW engineering.
But all that changed thanks to skydiver and wingsuit pilot Peter Salzmann and his world's first electric wingsuit.
What sets this amazing invention apart from conventional wingsuits is the innovative propulsion system. Unlike conventional wingsuits that rely on gravity and airflow naturally, this revolutionary prototype has a twin-rotor propulsion system built right into the chest section. This remarkable design provides pilots with great advantages: longer flight durations, controlled acceleration with accuracy, and, most amazingly, the ability to climb vertically mid-flight, something that, up until now, was not possible for wingsuit pilots to do. The initial manned flight of the prototype was a historic milestone in aviation, sailing from a helicopter at 10,000 feet over the breathtakingly beautiful Austrian Alps. Salzmann piloted a flight that would set new limits for human flight. During the flight, he powered up the jet engines in a moment of suspense, performing something no wingsuit flyer had ever attempted. He shattered all the previous records of speed, distance traveled, and navigation accuracy. Already in progress, this revolutionary endeavor is a quantum leap ahead of existing wearable aviation technology. The union of light electric turbines, cutting-edge aerodynamic materials, and user-friendly body-controlled navigation systems equates to a sweet union of shape and function. This accomplishment illustrates how creative engineering is able to make seemingly impossible concepts into a useful reality, setting the boundary for what humanity thought was possible in personal flight technology. Switzerland's human jet. Far up in the Swiss Alps, far above the mountains, one is presented with a marvelous spectacle: a single person flying across the sky on a device no more advanced than a specially designed jet propulsion system strapped to his back. Not fantasy Hollywood, but the real world, dreamed up by Yves Rossi, the legendary inventor who civilized flight. Rossi was a fighter pilot who was born in Italy. He drew upon his vast experience in the skies to come up with an unorthodox solution: a light but rigid carbon fiber wing and a cluster of diminutive turbojet engines. His design eliminated both cockpit protection and normal landing gear on traditional aircraft and employed just two fixed wings and manual thrust controls, helped along by sheer willpower. Early in the 21st century, Rossi achieved international acclaim with a record-making feat. Launching himself from an airplane platform, he activated his propulsion units and began traversing the alpine landscape. As a human airplane, he cut through mountain air at speeds exceeding 180 miles an hour, nimbly navigating narrow mountain channels and executing pinpoint aerobatic maneuvers and maintaining steady altitude through minute shifts in body position. Far beyond mere exhibitionism, this demonstration was the ultimate confirmation of human capability, a human being extended by jet power, exhibiting total command of three-dimensional space unfettered by the constraints of normal aircraft.
Take a look at this. Steering with only his body, Yves Rossi flew at more than 180 miles an hour before landing safely.
Rossi's subsequent successes continued to shatter barriers. He accomplished flights over the Grand Canyon of America and England's historic waterway, paving the way for the unmatched feat of synchronized flight with commercial airliners. However, his revolutionary jet-wing design has one fundamental flaw: it lacks the aspect of vertical takeoff, and it has to be, therefore, launched from an aircraft in flight. America's crowd-stunning rocket belt. The H202 Jetpack performs exhilarating aerial tricks above stadiums with amazing 30-second flight stunts. One of the most ambitious US public performance jetpacks, this record-breaking plane is the masterpiece of Jetpack International. Picking up where the 1960s rocket belt left off, the H202 introduces contemporary innovations without sacrificing the spirit of the original. Its propulsion system is powered by the decomposition of hydrogen peroxide, which is catalytically decomposed into high-pressure steam to drive twin-thrust nozzles and thereby propel the pilot through controlled aerobatic maneuvers. Despite its brief 30-second active flight duration, each flight is a demonstration of incredible dynamism. Pilots perform vertical takeoffs, flip in mid-air, and travel long distances over arenas, rooftops, and waterways, making the equipment particularly popular for live events, sporting events, and promotional events. American technological expertise developed this high-tech suit, and Troy Widgery, founder of Go Fast Sports and Beverage Company, played a key role in securing sponsorship for the Jetpack's groundbreaking international demonstrations. Characterized by its distinctive sonic signature and retro-futuristic aesthetics, the H2002 is less about practical transportation solutions and more about spectacle, a reflection of just how far personal flight technology has progressed. Maverick Jetpack. Did you ever imagine flying in the air with just a jetpack strapped to your back? The Maverick Jetpack distinguishes itself from other personal flying devices with its revolutionary autonomous flight capability. You heard it correctly. Unlike conventional designs, this emerging technology eliminates the necessity of manual control or grip handles. It merely employs a smart mechanism where pilots can control movement by adjusting their posture. The experience is reminiscent of sci-fi spy film scenes, where heroes glide through the atmosphere like it's nothing. Consider this amazing leap in technology. Maverick Aviation has come up with this revolutionary jetpack with a number of objectives in mind. As beautiful as it looks, the focus is on enhancing aviation safety, simplicity of operation, and accessibility. With its ultra-lightweight functionality and streamlined control panel, the Maverick Jetpack is a promising driver that democratizes personal flight. Just imagine yourself soaring through the skies without human intervention. The ride is smooth and forward-looking and is precisely what we envision when we look at the world tomorrow. However, the possibilities stretch much further than current limitations. The Maverick Jetpack is shown to be fantastically versatile, with immense potential in far-flung uses. Everything from rapid response rescue operations to tactical operations. With this technology ongoing, it is nothing short of thinking about whether such jetpacks might become a standard part of the everyday world, much as the concept of air vehicles was once imagined. But what if jetpacks weren't just about upward thrust? What if they redefined how we stand, move, and dominate the skies? What if the future of flight didn't sit on your back, but clung to your feet like a second skin? Could the next leap in aviation come from a man who used to race waves instead of wind? France's Sky Surfer. The concept of a working hoverboard defying gravity and soaring to 10,000 feet was once pure fantasy. But then came Frankie Zapata, a creative French inventor who started out as a competitive jet skier. One of the most revolutionary personal flight devices ever conceived, the Flyboard Air is an engineering wonder. Whereas other systems are fixed on the operator's back, this genius invention is cleverly strapped to the feet. Powered by 5 turbojet engines, the Flyboard Air flies at incredible speeds of 146 miles per hour. Its most remarkable aspect is its complete independence. Not like other systems that fly dependent on limited water hoses and wires, but instead relying solely on raw propulsion energy and stability. Zapata shocked the world initially in 2016, but his greatest achievement was in 2019 when he successfully flew across the English Channel on this amazing device. The historic crossing demonstrated so much more than the mere technical feasibility. It confirmed the Flyboard Air's capability for sustained flight times, high speeds, and substantial altitudes. Then, Zapata has dedicated himself to developing military variants and collaborating with defense departments, perhaps ushering this amazing innovation into a revolutionary battle weapon. What's most striking about this technology is its intuitive control system. Pilots steer it completely by slight body weight variations. Instead of merely flying the device, riders essentially surf on air. Thanks for watching. If you enjoyed this content, please leave a comment below with your thoughts, and we'll see you next time. Until then, stay curious.